Hi guys, and welcome back. I'm slowly starting to learn your names as more and more work gets turned in. Thank you very much. I just want a quick little reminder that coming to the Zooms, coming to my live Zoom lessons, doesn't mean that you don't have to do any of the other work on my class page. Still need to do that work and get it submitted so that we can get the grades into the grade book. So this week I'm going to be talking about scientific method. The scientific method, you've got a goofy little song that you're going to listen to. It's going to be stuck in your head, at least for the rest of this week while we do scientific method. I'm going to pull up a little PowerPoint here to kind of introduce this idea. Here we go. We're going to start with, how do scientists investigate the natural world? This was kind of our overarching question for really the last couple weeks. How do scientists investigate the natural world? And really our answer is through observations and inferences. So we make quantitative and qualitative observations, and then we draw conclusions and also make predictions based on that. Let's see what you remember. You need to decide if the following statements are quantitative, qualitative, or an inference or a conclusion. So our first one says there are 17 straws in the milkshake. Take a minute and think about it. Hopefully you said that it was a quantitative observation. Quantitative means quantity, and that 17 for 17 straws is what makes it quantitative. The next question, the substance in the cup is a milkshake. This one was an inference. This was a conclusion based on your qualitative observations. So qualitative, you could feel that it was cold. You could taste that it was sweet. Maybe you could even smell it. Next one, the dog is yellow. This is a qualitative observation. It has a quality. You can actually see that the dog is yellow. And the last one, the dog is kind. This is an inference. You're drawing a conclusion. You can look at the dog and you can see that its ears are like alert, but not back like it's angry. You can see that the dog comes up and you can feel that he like licks your hand. Oftentimes a dog will lay down, roll over, and show you their belly if they're going to be submissive. So you can draw a conclusion then that the dog is kind. So with these observations and these inferences, we can tie them all in, pull them all in together into our scientific method. Now we always start by asking a question with a scientific method. And in one of your discussion posts on my class page this week, I'm asking you to generate or come up with a question. Once a scientist has come up with their question, then they come up with their hypothesis or their prediction. Remember, a prediction is an educated guess about what will happen based on past experiences. A prediction is not your inference or a conclusion. That happens at the end after you've done the study. So you ask your question, you make a prediction. The next thing is you do an experiment. Now you might have to make up the experiment, or maybe you'll be following a series of steps. This week your lab is going to have a series of steps that you'll follow. Make sure that you watch out for your constant. And a constant is a variable that doesn't change. It's the thing that you hold the same when you're comparing two things. And when I do the example in a few minutes, I'll reemphasize that constant. Next, we take all of our information and we might put it into a graph, but we analyze our results. It might just be based on our observations, or it might be a graph that we put it into. Next, we draw a conclusion. This is our inference or our educated guess based on our results. And then the last thing we do with the scientific method is we share our results. Can you imagine if scientists never shared the results? We would have no cures for cancer. We would have no answers to what's going on in outer space if they didn't share the results. So ways that they can share the results are, well, the internet. It's probably the best way to share the results nowadays. So I'm going to run you through a quick little scientific method here. And I got to get my lab set up. So, okay, guys, so I've moved us into the kitchen here. And what we're looking at is a question that's going to ask, what is the fastest way to melt butter? So taking a little look here at our scientific method, and you're going to have to just kind of look on my screen. It'll be kind of tiny on the side there. But we started by asking a question. And the question I'm asking is, what is the fastest way to melt butter? So you ask a question. After you make a question, you have to come up with your hypothesis or your prediction. So my hypothesis or prediction is that I think cutting up the butter and using the stove is going to be the fastest. So I've got I took a stick of butter, I cut it in half, and then the next thing I'm going to do is I'm going to chop up one of the pieces of butter, and I'll put it in a dish for the microwave. And then I'll take my other piece of butter and I'm going to chunk it up and I'm going to put it on the cooktop. Now let's talk about what the constants are. Remember, a constant is something that we keep the same. So what did we keep the same between our microwave dish and our cooktop or our stove dish? Well, I made sure that we had equal amounts of butter for both of them. And I also made sure that I chunked them up the same way for both of them. So the constant was equal amounts of butter, and the butter is in the same shape. So now what I'm going to do is turn on my cooktop, and when I turn on my cooktop, I'm also going to pop my stuff into the microwave. So stay tuned. So as you can see, I am working on my experiment now. In my experiment, I would either write out or I would follow the directions to do the lab. So because I'm kind of making this lab up or inventing it, my steps were that I chopped up the butter, I put equal amounts into the cooktop and equal amount into the microwave. I started the microwave at the same time that I turned on the cooktop. And now I'm just timing to see which one is going to heat up the butter fastest. So you can already see this one. Oh, and guess what? Our winner is the microwave. The cooktop still has about half the butter left to melt, and the microwave has already melted its butter. So, what are our results? Remember, we talked about what our constants were. So, analyzing our results, well, I put equal amounts of chopped up butter into the microwave and on the stove. When I timed them, the microwave melted the butter faster. So after that, then I had to do my conclusion, and my conclusion is the microwave is the fastest way to melt butter. Well, my conclusion doesn't match my hypothesis or my prediction. That's okay, folks. All good scientists realize for every 100 experiments they do, 99 of them are going to be wrong or inaccurate. That's fine. That's part of science, is being willing to make those mistakes, coming up with a conclusion that shows something different than what you were predicting. So what we would have to do is go back and redo the experiment until we get a conclusion that is accurate. So the very last thing I have to do then is share my results, which I've already done with you. So to wrap things up here, the scientific method has those 5 steps to them. Now, sometimes those steps get drawn out a little bit more, but those really are the 5 basic steps. Go ahead and watch the goofy little song video that, like I said, will be stuck in your head for at least the rest of the week. Do that discussion question, and then you're going to have a lab for me. And that lab, look for a penny and an eyedropper to get dropped off probably on Tuesday of this week. So you might not be able to do the lab unless you have your own penny and eyedroppers at home. But I was trying to keep things constant between everybody by making sure that you all had the same type of eyedropper. So that will be coming on the buses this week. You're going to be trying to answer the question, how many drops of water can you fit onto the top of a penny? All right, scientific method. Good luck with your lab. Stop into my office hours. I'd be more than happy to help you with anything. All right, miss you guys. Bye.